But anyway, welcome to the September webinar in our Best Practices series, sponsored by DataKinetics. And my name is Leah Manzoor, and I'm the Vice President of Sales for DataKinetics, and I'm going to be your host today along with Scott Quillicy. So in this webinar, we're going to be addressing upgrading your current data replication solution, whether it's for DB2, IMS, or VSAM. And we're also going to focus on the mainframe being a component, whether that's going to be a target or a source for data replication. And then we'll also discuss open systems for the cloud being targets for data replication as well. So before we start, I just wanted to thank everybody in advance for sharing a little part of their day with us, and we're delighted that you've been able to join us today. So as we go through the presentation, as Sheena mentioned, if you all have any questions, we encourage you to go ahead and log it in the question box, and then we'll address the questions at the end of the presentation. So, Sheena, can we go back one slide? Is that possible? There we go. So I want to talk a little bit about our agenda. So we're going to talk a little bit about DataKinetics as a company, what we do, and who our customers are. And I promise to keep it very short and sweet. Then we'll talk about upgrade considerations. So maybe you want to replace a single-purpose replication product, or maybe your business now requires a more integrated solution and you need more functionality like near real-time latency. And then we'll also talk about the need for high availability and change data capture and event publishing in the common replication scenario. And then we'll review the replication architecture. And then lastly, we'll discuss the conversion process, so defining those activities that you'll experience in a conversion and recommend some best practice success factors for you. So DataKinetics as a company. So we're founded in 1977, and we've been solving IT problems and reducing IT costs for the proverbial who's who of the Fortune 500. And we do this via a dedicated team of technical and service professionals that focus on delivering enterprise solutions to the most challenging of the problems that you all face every day. So we're a leader in data access optimization, and our products address like optimizing application performance using in-memory processing. We also optimize data movement and integration, and we optimize database performance as well. So we're a privately held company. We're based out of Ottawa, Canada, and we also have regional offices across the U.S. We're also a long-standing IBM Advanced Business Partner, and we have an international set of customers across the global 500. So as you can see, 20% of the Fortune 50 use our product, as well as all the top 3 in these different vertical markets, such as banks, credit card companies, insurance companies, and healthcare companies. And these are all long-time customers. So we have been working with these folks for a combined total of over 1,000 years. And we also have a 100% retention rate, which is no small feat these days. So you've probably heard of some of our customers before. These are the virtual cornucopia of blue chip companies. And these folks don't trust just anyone with their most mission-critical business applications for optimization. So we've enabled these top data centers to overcome some of today's challenges like data access, performance and capacity, and we power over 1 billion mission-critical transactions every second of every day for these companies, and that's no small feat. So some of the use cases these companies use our technology for. So on some of the credit card companies, they use this for fraud detection and alerting. Some of the financial organizations, they use this for consolidated financial statement processing. Some of the loyalty companies, our loyalty programs of the retailers, they use us for loyalty program detection and also use our rules on the fly and in real time. And then a lot of the other organizations use us for enablement of big data analytics for both BI and cloud migration. And then, of course, we do the maintenance of those older legacy applications for the larger companies. So our customers use our technologies because we save them billions of dollars every year. And we do this by reducing the cost of overall transaction processing for them, and many times up to 98% faster. So we reduce the cost of data movement. We reduce the cost of DB2 data access. We also eliminate CapEx spend and reduce their overall OpEx spend as well. So with that, I'd now like to introduce a partner of DataKinetics, SQ Data, and Scott Quillicy, who's out of Irving, Texas, which is a burb of Dallas, is the CEO of this organization. And Scott's going to be talking about how he built the technology around the best practices that some very large companies enjoy today, such as Bank of America and Bell Helicopter and AT&T. So with that, a hearty welcome to Scott. Scott?
Thanks, Leah. And I'd like to thank everybody for attending this morning. I think we've got a pretty good show for you, so just sit back and enjoy. And like Leah said, when any questions that come up, go ahead and type them in the box, and we'll address those at the end of the presentation. There we go. SQ Data is we founded in 2000. Our first product came out in late 2001, and it was really based on change data capture. I was previously with IBM, worked with a lot of the replication products and database performance. And one thing that stuck out was the lack of a really good change data capture technology. So that's what we built SQ Data in mind to address that need. We started with IMS and then moved on to relational, and now we support a whole variety of different sources and targets. It's really like a Swiss Army knife, if you will, of data replication tools. So as far as best practices go when selecting a replication tool, you want to find a single tool that solves multiple challenges. So and that's very important. You look at other vendors and you'll find that you have to buy 4 or 5, maybe even 6 products depending on the number of sources and targets you have. With us, it's a single tool that solves, like Leah said earlier, multiple business issues. But the change data capture, people use it for a lot of different things. We'll get into the details as we go along. Okay, so why are companies upgrading? The main reason they upgrade is because they currently have older single-purpose replication products. I won't mention names, but if you've got something that's been around since, say, 98 or earlier, then you know what I'm talking about. These older replication products are single-purpose, don't do much more than replication from like a source A to source B or target B that looks identical. But customers are needing more capability than just straight replication. They need a true integrated solution. The other reason is the older products don't provide near real-time latency. And with things moving the way they are, especially with the big data repositories, people want near real-time delivery, not 5-minute old, not an hour old. They're talking sub-second. The current product is not receiving significant enhancements. There's a couple of vendors out there that basically have sunsetted their products or gone into maintenance-only mode. They'll still sell it, but no exciting new enhancements. If you want an enhancement, like for example Hadoop support or Cassandra or MongoDB, in the big data space, you're probably looking at another product in addition to the one you currently have. And then cost is big. The value of the current product doesn't really justify the expense in terms of annual maintenance and or, most importantly, CPU cost on a daily basis. So the success factors in tool selection. The tool you select has to have capabilities outside of general replication. It can't just do identical replication from A source to B target. It needs to have a consistency checking, a rematerialization strategy built in. Allows for you to identify conflict detection. We'll get into that in a few minutes. It should not require multiple products. For example, it should not require that you have MQ installed. MQ is used for some replication products. It's heavy. We'll get into that in more detail here in a few minutes. It needs to be able to run on multiple platforms without other products, and then it needs to be able to work with other data integration products, ETL, particularly like a data stage or Informatica Power Center. That's already been there in place, the business logic's built in, so the tool needs to work seamlessly with those products. The conversion, once you decide to switch, should be completed rapidly. It shouldn't be a year effort. It shouldn't really even be a 6-month effort. It should be, in the case of, say, relational, a multi-week effort at best. And you have to have a clear validation plan. We've done this for a number of years, and so we guide folks through the conversion process to streamline everything. We don't want to do it with a lot of people. It should be done with minimal personnel. As far as ongoing operation, you need to make sure it's fast, of course, reliable, and efficient CPU-wise, and of course easy to maintain. Shouldn't require constant attention. It should be set and forget. Should be able to handle volume spikes. So the high volume customers, you know what I'm talking about. Batch runs, how far behind does the capture get? Can the capture even handle it? In some cases, some of the older products just can't handle high volume. And high volume in our vernacular, anything over, say, 100 million updates a day is considered high volume. Extreme volume is in the, say, 300 or 400 million, maybe higher a day. The tool needs to be able to handle that. And it should be able to fold into your existing processes, not introduce a new one. So how is replication being used today? More, how is change data capture being used today? Well, we see that over half of the customers using change data capture replication is for data warehousing, business intelligence population. 28%, believe it or not, is event publishing. And what that means is as you're capturing data, look at it, see if something is of interest, and say format an XML message and put it in a queue to send to a downstream application. Very commonly used for fraud or any kind of event where the value of the data is a business event that you want to notify people about. As soon as it happens, we're talking sub-second. High availability is coming on strong, and that's where, for example, the old DR, the classic active-passive, we have some slides on this. And then we have a few folks that use it for audit. Who changed what, when, and what did they change? So let's move into some common replication scenarios. The first one is continuous availability. That is, you usually set up two ways, active-passive, or the active standby, the historical. Now, you can see we have IMS here in DB2, but it could just be Oracle, SQL Server, anything we support, but these are for illustration purposes. So active-passive is you have an active side, and you're replicating everything to a passive side, or DR side. Just in case something happens, you can switch over. The bottom part, active-active, is more common with the larger customers now, where they have multiple data centers. And they're updating both sides at the same time, and they need to keep those in sync. We're seeing more and more of that with larger customers, like I mentioned, and it's becoming the norm. So the tool has to be able to handle both. Now, the next slide, active-active with the selective routing. What we did was we have customers going active-active, and in the meantime, they want to spin some of this data off and send it to a data warehouse or someplace else. And so while you're capturing the data and moving it from A to B and back from B to A, you've got the data, you might as well ship it then rather than capture twice. What you don't want is a product that requires you to have multiple captures on the source side. That's expensive, it's extra overhead, it's not necessary. So in our take, capture once and apply many times. CDC Enhanced ETL. This is a big one for customers who have an existing ETL product. ETL being bulk loads, not great for near real time at all. The data may be a day old, it could be a week old, it could be a month old. People want brand new data. So the ability to enhance existing ETL processes with change data capture usually involves staging these changes in a place, a table or a queue normally, that can be picked up by the existing ETL tool and then applied using the existing business logic. Event publishing. We've touched on this earlier, but event publishing is you capture, and as you're capturing the data, you're looking at it. In the event, you find a value that is of interest. For example, we have a customer who looks at claim data, healthcare claims, and any claim over $500,000 is an event that they want to send to fraud. And it could go somewhere else as well, but in this case, particular use case, it does go to fraud to find out who's submitting a claim for over $500,000. It might be legit, it might not, we don't know. And there's other factors that they look at as well. You know, who's the provider, and they have a whole list of criteria to determine whether an event is something that needs to go downstream, or it could just be discarded and you move on to the next record. The last case is audit. Historical tracking is pretty straightforward. Capture and then stage all of the changes in a table usually, but it could go into a big data repository, but most of the time it's a relational type table where when the change was made, whether it was insert, update, delete, who made the change, what the object was that changed, and then what actually changed from in an update. For example, you'd want to know which column changed and what it was changed to, and that's what audit allows you to do. So the tool really needs to be able to perform all of these from the same footprint. Okay, now we'll get into the components and architecture of replication. There are four basic primary components. You've got the capture, which is important. You want to capture changes as they occur in a very rapid manner, sub-second latency. In some of our higher volume customer shops, we see 100, 200 millisecond latency. It's pretty quick. So capture has to be very lightweight and be able to handle high volume. The second component is the transport component. So you capture data, you have to send it somewhere. And usually that goes to an apply component. The apply component is where all the heavy lifting is typically done, and that's the business logic, the mapping, translation, say from relational to non-relational or non-relational to relational, and everything specified usually in an apply component. So the capture itself is in charge of just capturing data and publishing it. The apply, again, does the heavy lifting. And the fourth component, which is very, very important, is a consistency checker. You need to have the ability to check source and target consistency to make sure it's in sync during replication. It's not a matter of if you get out of sync, it's a matter of when. And usually 99% of the time human error causes it, but and it may go undetected for a period of time. So you want a consistency checker that can run in the background and give you the peace of mind that your databases are in sync. Transport. We mentioned this before. There's two basic methods of transport. Queues, MQs, is widely used by several replication products. The nice thing about queues is it manages the transient storage in addition to moving the data. And they're reliable, it's resilient, it can handle, it says high data volume, but it's really moderate. Too high depends on how much CPU you want to take to do it. It does add a moving part to the mix, and typically they struggle with very large messages and large units of work. It becomes a burden, in our opinion. The second method is TCP/IP. So you're taking like MQ down to the next layer at the IP layer, where it's much faster and more efficient than queues. You can handle extreme data volumes, reduces the number of moving parts, and much lower CPU consumption than with MQ. Very, very reliable. The key is to not dim the lights when you're doing replication, especially in a high volume environment. Everything, the cost of all your software goes up when you do that, especially on the mainframe. On capture, we'll talk about IMS a little bit. There's data capture exit routines, log-based, application-based, and hardware. So we're going to talk really about the first two because the application-based has its own set of issues. It's custom usually. People can forget a program, or anytime you want to capture new data, you have to do an application mod. We won't touch on that one very much. Hardware replication is good for active-passive. You can't go active-active with it. That's an inhibitor. Now, in database exit routines, near real-time, very, very scalable. You can use, in our case, MQ for persistent storage and transport, but you don't have to. And it doesn't require the hex 99 log records. So the IMS customers will definitely appreciate that. You don't want to double or over double your logging. It's a critical component of IMS, and the less you can stress him out, the better. Log-based is for customers who are mostly CICS-DB control. It can be near real-time or asynchronous. Does require the hex 99s, so high volume shop, it could cause a problem. Just be aware of that. I know a large bank right now that is running hex 99s. They're not happy, but well, they're not running our software, so I guess that's a good thing. But they're not very happy with their solution just because of the overhead of the logging. This slide is an example of the SQData IMS replication, our CDC store. We use our data capture exit. You can see that you can run sysplex, extremely high volume, and then from the transient storage in the coupling facility, a publisher's component sits on top of that and pushes those changes downstream to one or more apply engines. Very, very fast, extremely scalable, and you don't even notice it's there. For the logging, this is an example of a three-way sysplex where you're capturing data from the IMS logs near real time, and basically the capture is a threaded component that reads multiple subsystems concurrently. There are some issues associated with that. You know, if one is a little bit slower, if one's down, that kind of thing has to be taken into account by the capture. And then the publisher component would work the same way. He doesn't really care that it came from the logs or the data capture exit. It's generic, and then his job is to take units of work and publish those downstream to one or more applies. Okay, let's talk a little bit about DB2 replication now. You've got three classes of DB2 replication. The first one being log analyzers. We refer to this as a poor man's method of replication. It does okay. It's not full function. It typically just replays SQL, but any kind of advanced conflict detection, exception processing becomes a very difficult endeavor for somebody trying to use a log analyzer for replication. We do know of folks using those, and it works okay, but anything advanced past just replication becomes a big, big problem. Second category is you have your single-purpose data replication products. Again, they do heterogeneous or homogeneous, rather, replication like DB2 to DB2. If you want more functionality, you're looking at additional products. And then the third category is a multidimensional product that's heterogeneous, so it handles relational and non-relational. It does the ETL, the bulk loads, the initial loads of the full set. It does replication, does event publishing, and just general data integration. So you really want to look at the third one. Now this next slide is what you don't want in a product. This is if anybody who's running one of the older DB2 replication products, you're familiar with the setup here, where capture actually captures the data from the log, DB2 logs, and stores all of that back in DB2. And then from there, you have subscriptions that read those tables and then apply those to a target, usually local. That is an extremely expensive setup. You want to stay away from overburdening, whether it's DB2 or Oracle or anything, with extra work. In our case, the next slide, no DB2 overhead, and this setup, which is optimal, just happens to be ours, but we like to think that we build our technology based on best practices, is to not text DB2. Rather, keep him running and servicing the applications versus taking up a lot of resource for replication. I mean, you're talking logging, you're talking having to maintain those staging tables, and in this case, you're looking at about a 50 to 60% CPU savings just by getting that overhead out of DB2. Very, very significant. Okay, moving on to the conversion processes. The success factors in a conversion is you want to automate as much as possible. 90+% is a goal. It can be higher depending on the complexity of the interfaces that you're trying to convert. The more complex ones would be, say, an IMS to Oracle, where there's an older IMS database as a source, perhaps built in the 70s or 80s, where space was a real concern. There's bitmap fields, and we've seen every kind of Y2K implementation, I think, so far. It gets a little more complicated, but for straight replication, where you're replacing a single replication product, single-purpose replication product, it should take a week or less. Very straightforward. It almost should be like a utility. You shouldn't have to spend much time on that at all. As far as resources, make sure you have a good DBA. System programmer will do the installation and configuration typically, and then they kind of stand out of the way, but DBA becomes involved. Security, very important. Normally in a conversion, that's where you're going to see a lot of delays, is getting security authorizations and such. Most important are the application subject matter experts. They're the ones that understand the data and understand if the replication is working like it's supposed to based on the data itself. They're also the ones that will be doing some of the validation or bulk of it. The consistency checking component of the tool should do a lot of it for you. But in some cases where it's a little more advanced, you might need the application subject matter experts to chime in as well and build some queries. But overall, it shouldn't require an army of people. It should require just a couple of guys, and that's it. It should be not a tax on the resources. And as far as vendor support, make sure your vendor has the expertise in replication. They specialize in replication would be preferable. Like us, that's all we do is data replication and integration. We've been around the block a number of times, and we can certainly help avoid common pitfalls. The second thing is the vendor's willingness to provide timely assistance with any kind of issues, including enhancements. So you don't want to pick a tool to where you suggest an enhancement, they'll come back and say, we'll take that as a recommendation or a possible line item for the next release, and oh, it'll be ready in 15 months. You want a vendor who can actually provide something in a very, very timely manner if you need it. So what's involved in conversion? It's identifying source and target. I say tables here, but it could be segments, it could be other objects. They're typically defined in the existing replication setup, so it's not terrible. It's just a matter of getting a roadmap of your sources and targets. And normally what we see is that they want to include additional tables as well. Not just say the 600 tables that they have in their existing setup, but maybe another couple of hundred of new tables. And in that case, the subject matter experts typically define the source and targets of interest. And you want to install and configure the tool, create the source to target mappings. Again, automated, 90% plus or higher is good. Again, the manual part would be any kind of special business logic, filters, special processing, and so on. The next step is to deploy and run, first in test, but then get to parallel production as quickly as you can. That's where we see the real data anomalies pop up. And so what you want to do is create a shadow of replicated targets, new capture against the original source to the shadow targets, and at some point what people do is they switch over from the shadows to the live. And so everything's set up, you can do your comparisons and run them side by side until you're ready to cut over and then switch. The validation piece, again, consistency checker, and I bring that up a lot. It's very, very important, and then just verify that the results are correct. It's nice to have a regression suite of queries or custom validation routines in the event that you have complex business logic or something like that, that if you change something, you want to make sure the results are still what you expect for other interfaces. And then once everything looks good, cut over to the new tool. But it should be a very, very painless process requiring minimal personnel. Okay, my favorite subject. In order to verify source to target consistency, you have a couple of challenges. First, the data moves a lot. There's no, oh, let's take everything offline and read only, unload both sides, and then ship one unload over to the other side and do a compare, which could take hours. That's unacceptable these days. Everybody's running 24/7, high availability applications. You need to be able to check the consistency during active replication. So the component we have, we call it live check. It works with or without SQ data. It can be run standalone. So if you have another product that you're using for replication and you want to check her, we've got one if they don't have it. But what it does is monitors both sides by key ranges, calculates a hash, sends the hash to the controller who determines whether they match or not. If they don't match, then we'll cut it in half, cut the range in half until we find the exact records that are out of sync. And then through the control center, actually present that information and allow you to fix it. Sheena? We still good?
There? Yep.
Next slide.
Yep. Hang on there.
There we go.
There you go. Okay. Sorry about that.
To summarize, much better, much better. To summarize, when you're doing a replication tool upgrade, tool evaluation and selection is paramount. You want to meet your current business requirements and also be ready for anticipated future business requirements. Most shops know what's coming down the pike. They can look out a year, 2 years, 3 years and see. You want to be able to have a tool where you don't buy two, buy one, and address everything going forward. Now for ZOS, you have limited choices available. For IMS, for example, you may have 2, 3 products in the world that will satisfy your need for replication, event publishing, and so on. There are other products out there, but if you're in any kind of high volume or enterprise class setup, they just won't do the trick. So stick with the top 3, SQData being one of them, of course, on the ZOS side. And again, fitting into existing version control, change management process is key. You don't want to introduce another set of processes. It's just disruptive and prone to error. On the conversion side, again, automated is good. The more the better, and it should be completed in a very, very short time frame. Unlike typical application development, the conversion for a replication upgrade should be one of the shortest phases of the project. Validation, again, minimal personnel. Use the consistency checker. Validation typically is the longest phase of the effort, just to make sure. And normally what happens, in a straight replication setup, it doesn't take very long. But if you have complex business logic or you're going non-relational to relational, it could take a little bit longer. And so you have to keep that in mind as well. Vendor support, again, experience. Make sure your vendor has experience with data replication, design, deployment, best practices, and avoiding common pitfalls. And again, willing to provide a quick turnaround on customer-specific enhancements, in addition to questions on operations and such. So that's all I have for today. Do we have any questions?
Okay, if anyone has questions, feel free to type them in the box at the bottom right of the screen. And as a matter of fact, Scott, one just did pop up. What type of performance benchmarks have you seen with your product over IBM's data propagator?
Oh, that's a great question. That's one of my favorites, actually. We see that a lot because some of the dprop, data propagator, dprop is going out of service, end of service, and so customers are looking at a replacement. But for that particular product and the current SQL replication, which is really a add-on to dprop, if we're talking DB2, we would see a 50 to 60% improvement in CPU. And speed is near real-time versus 5-minute latency or multi-minute latency.
Great. Okay, here's another question. Outside of your product, are there any additional software required to replicate mainframe DB2 data to Oracle?
No. The answer is no. Everything works out of the box. You don't require a separate product out there, some kind of special server. No. All comes out of the box as a single product.
Okay. And this one, I'm not sure if you want to answer this one, but how does SQData stack up against Oracle Golden Gate?
That's a great question. We actually ran up against that last week. I was at a customer site, and that question came up. They actually helped us out with it. Golden Gate is a great product for pure replication. Very, very fast. If you're doing straight Oracle to Oracle identical copies, it is, we would recommend you go that route. It's not a bad product. It's a little bit pricey since Oracle bought Golden Gate, but it's a pretty good product. I will say, I'll be the first one to admit that, and you'll learn that if you work with us, that we, say it like it is. And so Golden Gate is a very, very good product for Oracle to Oracle replication. However, if you want to do anything outside the norm, then you're looking at having to purchase the Oracle Data Integrator, and the ability to actually do anything of a serious nature, complex nature, becomes a very big challenge. We've had the comment last week was very complicated, too complicated. We don't want to go that route because they weren't doing straight replication. And the last thing about Golden Gate is if you're doing anything on the ZOS side, it works, it runs, it's not their forte. The forte for Golden Gate is Oracle and perhaps SQL Server on the target side. But past that, on the ZOS side, keep looking. That would be my suggestion. I'd go with IBM before I go with them on the mainframe. And if you've got non-relational, say BSAM or IMS, good luck, it doesn't support it. So it's really a subset of a multi-purpose data integration product. Long-winded question, but or answer.
No, that's great. That's great. Okay, now it looks like one last question here. CA has announced that they are sunsetting a product called Info Refiner. And SQ Data was mentioned as an alternative. How long does it take to convert from Info Refiner to SQ Data?
That's another good question, Leah.
You know, I had heard that someone else had mentioned that there was a CA announcement that actually recommended that they look at SQ Data.
Mm-hmm.
I haven't seen it yet, but I heard that.
Yeah, we get quite a few. We've got two. We just finished one up and working on another, and it looks like we have yet another. The sunset's happening quick, and I think people are scrambling. But to answer the original question on how long it takes, it's kind of like saying how long is a piece of string. The one that we just finished was extremely complicated. The original design that they did was not what we would consider best practices, so there are some hoops to jump through. Overall, though, it probably took 3 or 4 months to actually get the conversion done and the validation cleaned up.
Okay, great. Okay, do we have any other questions? Oh, here comes one. Last question so we can stay at that 45-minute mark. How is the ASCII EBCDIC format set up with the tool to transport delivered data to the platforms that work with different platforms?
Oh, I guess you're talking about EBCDIC to ASCII. We'll take that down another notch and call it code page, whether it's an EBCDIC code page or a ASCII code page. They're all basically the way the data is stored. That should be handled by the tool. It should be transparent completely to the user. And so whether you're running one of the dozens of commonly used CCS IDs on the mainframe side, I don't know, 1208, 1047, and the traditional 37, to go to ASCII should be seamless. You should not have to worry about that. The way we do it is the translation actually is done on the target side. So the data is, if it's captured on mainframe, it's shipped over in a condensed format in the original code page. And so if it's on a mainframe code page EBCDIC, when it gets to the apply, it's still in EBCDIC format, and the engine will actually take care of the translation, depending on what the target is. Very efficient, and it keeps the capture from having to do any kind of translation.
Great, thanks, Scott. Okay, any other questions that anyone has? Okay, well, with that, I want to thank everybody for their time today. You know, we understand everyone's time is precious, and we hope we gave you some insight into some data replication best practices, and hopefully you were able to gain a little bit of knowledge from our presentation today. So if you have any comments or suggestions for us for future webinars, we'd love to hear them. You can forward suggestions to us, actually to me, at lmanzoor@dkl.com. And with that, have a great day, and thanks again for participating in our Best Practice series. And Scott, thank you very much as well.